In this video, we'll continue solving systems by graphing, and as a reminder, we'll see that the solutions of the system are intersection points or points of intersection of the lines. That is the common point. When you find the solution, make sure that you replace it in both equations to see if it makes true statement. If not, have to go back and check the graphing. So there are three possible types of solutions. If two lines cross, they will always cross in one point only. If you have parallel lines, the parallel lines will never cross. There will be no solution. And for overlapping lines, we have infinitely many solutions. So we'll look at a few more examples that have some details that I'd like to point out. So example number 4 in the same lesson, we'll have the system, and we're going to start with graphing by transforming to slope-intercept form. Y equals mx plus b. And the first equation has negative 2y equals negative 10. This equation has only one variable. If the equation has only one variable, it means it's either horizontal or vertical line. The y is multiplied by negative 2. So by using inverse operation and dividing by negative 2, y equals 5. So this is a horizontal line going through 5 on the y-axis. If y equals 5, it means that we need a line where all the y coordinates are 5. 1, 2, 3, 4, 5. On this horizontal line, all the y coordinates of every single point are 5. We have x minus 3y equals negative 9, the second equation, and we'll transform it to slope-intercept form where y equals mx plus b. So this is the goal to get to. This is the original equation. Subtract the 1x from both sides. Bring down the negative 3y and regroup the x term and the constant. X term first, minus 9. Negative 1x minus 9 cannot be combined. They're not like terms. Divide by negative 3 and simplify. Y, or 1y, y alone will equal. Negative divided by negative is a positive 1/3 slope. Negative divided by negative is a positive 3 y-intercept. So that means that the line has to go through 3 on the y-axis. How? Upward, because it's a positive slope. What count? 1 by 3. 1 by 3. 1 by 3. Or the other way, 1 by 3, 1 by 3, 1 by 3. 1 vertical, 3 horizontal, or 1 rise, 3 run. The tilt or the inclination of the line has to go up to the right. Up to the right is positive slope. Solution is the cross point of the two lines is the location 1, 2, 3, 4, 5, 6 for x, 1, 2, 3, 4, 5 for y. So that would be 6, 5. Let's check that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. When we check, we have to replace both equations with x 6 and y 5. So in the first equation, negative 2 times y, that's 5, should equal negative 10. Negative 2 times 5 is negative 10. So that's a true statement. In the second equation, we have x, which is 6, minus 3 times y, which is 5, should equal negative 9. Multiplication first, based on the order of operations. 6 minus 15, and then 6 minus 15 is negative 9, which is a true statement. So by replacing our x and y values in the original system, both equations gave us true statements. More details. Example number 5 has 2x plus y equals 4, original first equation in standard form. Subtract the 2x, and the y will be negative 2x plus 4. That means we have to go through 4 on the y-axis with a negative 2 by 1 slope. So we have negative direction of the line, count 2 by 1, 2 by 1, 2 by 1, 2 by 1. The 4 was the y-intercept, so we know that the line has to go through 4 with a negative 2 by 1 slope. Second equation, x minus 2y equals 7. Using inverse operation, we'll subtract the 1x. Negative 2y will be negative 1x plus 7. The negative 1x is the first term, and the 7 is positive, so we put plus 7 because we want to group them up towards that slope-intercept form, y equals mx plus b. Dividing by negative 2, 1y gives us the y alone. Negative divided by negative will be positive, half, which is the slope, and then minus, because positive divided by negative is negative, 3.5 y-intercept. I'm changing the 7 over 2, which is an improper fraction, to a decimal because I want to graph that point on the y-axis. And 7 over 2 as a fraction is 3.5, where I have to go on the y-axis 3.5 squares. So I go 1, 2, 3.5, or 3.5 squares. So this y-intercept is not the whole number, and remember, it can happen. Don't always expect it to be a whole number. Now, when you graph the slope of 1/2, you have to make sure that we go from this 3.5 1 square up. That means from half to half. So from half to half is 1, then stay on that half and go 2 across. Okay, because you can't just use half square, you have to use a full square. So from half to half will be 1 square, stay on the half, go 2 across. Again, from half to half is a square, stay on that, go across. From this half to this half is a square, stay on half, go across. So repeating that a couple of times, make sure that we go from half to half to complete a full square. When you trace, so you have to be very careful. When you trace that line, you will see that intersection point right here, and the coordinates will be 3, -2. So when it comes to fractionals or decimal y-intercepts, you have to be very careful how you graph in order to create that complete unit. So 1 is from half to half, then stay on that half, go across 2. The lines will meet in 3, -2. Now we're going to check that solution, because if we're off a little bit? I don't know. We'll check if it makes a true statement in both equations, but you check it in the original system. Then we're right. So let's go ahead and check. X is 3, y is -2. In the first equation, 2 times 3 plus -2 should equal 4. 2 times 3 is 6. 6 plus -2 means 6 minus 2, which equals 4. That works. In the second equation, we have x value 3 minus 2 times y value -2 should equal 7. Multiplication first, so bring down the 3, and you can multiply negative times negative, or you can say minus but then -4 it will be still plus 4. Or you can multiply the signs right away. Negative times negative is 4. And then 3 plus 4 is 7. That works. So our solution 3, negative 2 works in both equations, makes true statements, so we found it correctly. The graph was done correctly, we found it correctly. And one more detail for horizontal and vertical lines in example number 6. X plus 4y equals 8, the first equation. 1x, we subtract from both sides using inverse operation. Bring down the 4y positive. Regroup negative 1x plus 8. 8 is positive, negative 1x is first, then plus 8. Dividing by 4, both sides or each term has negative 1/4 slope plus 2 after you simplify the fractions or divisions. So 4 divided by 4 is 1y or y. Negative divided by positive is negative 1/4. That's our line, negative. What is the line going through? Through 2 on the y-axis. Negative 1/4, negative 1/4. And then we can expand it the opposite direction. Extend in the line. When you connect, the line goes downward towards the right. That's negative. Count 1 by 4. 1 by 4. Second equation has only one variable. X minus 14 equals negative 16. So there is no y variable involved in this equation. So we just solve for the x. Add 14. When we add the 14, x value will equal negative 2. So this is our vertical line through negative 2 on the x-axis. It means that on this line, all the coordinates for x are negative 2, like negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 3, negative 2, 4, negative 2, or negative 2, negative 1, negative 2, negative 2, negative. So all the coordinates for x on this line are negative 2. That's the vertical line, x equals negative 2. So here is the solution. The solution is where the lines cross. This solution is negative 2 and then 1, 2.5. So this point is right in between these two. It is in between the 2 and 3, so that will be 2.5 or 2.5. So the y coordinate is not a whole number, which again can happen. It doesn't have to be always whole numbers because we have all these fractionals and decimals in between. So negative 2, 2.5. Reading this solution needs to be really carefully done, and you check it to make sure that it makes true statement in both equations. Now let's see here. The solution negative 2, 2.5 is negative 2 for x and 2.5 for y. Let's see if that one works. In the first equation, x is negative 2 plus 4 times 2.5 should equal 8. Multiplication first, so negative 2 plus 2.5 times 4, 0, 2, 8, 10 equals 10. And then negative 2 plus 10 is 8. That works. In the second equation, instead of x, we put negative 2 minus 14, and that should equal negative 16. Well, negative 2 minus 14, if we combine, we add the numbers, keep the sign, that's negative 16, which makes a true statement. So our solution, negative 2 and 2.5, works because it makes true statement by being replaced in both equations in the system.